All right, here we go. So we want to get more practice with the chain rule, and with this next example, we're going to chain chains, which I referred to earlier, and it is going to be a blast. So if we think of this function a little bit differently, we can start to see how many chain rules we're going to have to do. First thing is, if we see this as 2 to the x, right, as an exponential function, there's going to be that. But in the exponent we have the sine function, which is another chain. So that's stage 2 of the chain. And stage 3 is that we have the function just pi x on the inside, the third stage of the chain. So when I go and compute the derivative now, I need to take the derivative of the exponential function 2 to the x, which is going to be 2, and then sine of pi x, just leaving all that alone, and then times natural log of 2. And then I need to multiply this now, so this is stage 2 of the chain, so I need to now take the derivative of sine of pi x, so that is cosine pi x. And then I've taken the derivative of sine, and now I need to take the derivative of pi x, which is just pi. Okay? Okay, so just know that you could have these 2, 3, 4, 5 layers deep on a chain rule, on a single chain rule. So be careful with all this. You just can't simply differentiate and say, and actually this is very common for students to say that this is going to be 2 cosine cosine pi. Okay, I want you to think about why students might say that that's the answer, and then subsequently say to yourself, don't do that. Okay, so think about why students might say that, and then resume the video for this fun one. Okay, so this looks like a hot mess, and truthfully, it is kind of a hot mess. But I think it might be easier if we simplify this maybe just a smidge. And so if we write this numerator instead as x e to the minus k, minus k plus kx, that might make make our life a little easier. And then the denominator just says 2x minus sine squared 3x. Now to complete this problem, or to complete the derivative, we need all the toolkits that all the tools in our toolkit that we could possibly have up to this point. Okay, so we can do it. H prime. Alright, so where do I start? Well, it's a quotient. I have to do the quotient rule. So I have to do low 2x minus sine squared 3x to the 1/2 times d high. There's a product in the numerator. Okay, so I do 1 and then d2. So now this is a chain rule, e to the minus k plus kx times the derivative of the exponent, which is just going to be k, plus 2. So e to the minus k plus kx plus, or times d1, so times 1. Okay. Oh man, that was just low d high. Minus high, e to the minus k plus kx, d low. Okay, we got many chains here. So first thing is the 1/2. So I'm using the bar idea. Okay, so imagine two kind of differentiation bars moving in on this thing. So I'm going to have 1/2 and then 2x plus, minus sine squared 3x to the minus 1/2. Now I need to move inside, and I'm running out of room. Oh, just kidding, I have more room. You might run out of room. And then 2, so now I have to differentiate this inside. Derivative 2x is just 2. Now this is another chain rule. Minus 2 sine, so bring the exponent down, 3x. Now I take the derivative of sine, which is cosine. And finally, derivative of 3 is just, or derivative of 3x is 3. So that was within a chain rule. That was a 1, 2, 3 stage chain. Fun times. Okay, but then I'm done. And then this is all over low squared, which would just be 2x minus sine squared 3x. Okay, and then guess what? You get to simplify it. Just kidding. I would leave it like this. Okay, and so those two examples are an example, I guess, examples of doing multiple chain rules and literally using every toolkit that we have, or tool in our toolkit that we have: the power rule, the product rule, the quotient rule, the chain rule, and trig derivatives, all in one fun problem. And so keep that in, or maybe try this again in a week or two, just to make sure that you can do it in preparation for that differentiation gateway, where you have to get 8 out of 10 problems completely correct in about a half hour.